everyone, it's calculations time again with Dr. Dave. So we're going to continue discussing ratio and proportions into something that we term dimensional analysis. Now, dimensional analysis is nothing more but putting ratios together in an organized way. And I think the best way to show you what dimensional analysis is just to do an example of it. So if we have this example, it says how many seconds are there in 2 weeks? So our answer, what we're looking for, is seconds, right? And we're starting with 2 weeks. And we know we have to take 2 weeks and we start to break it down into weeks, days, hours, minutes, seconds. And to do that, if we did ratios, the way in which we're used to doing them from one at a time, we can say that, for example, in 7 days, there is 1 week, and we can say how many days, so x days, are there in 2 weeks, right? And then we get that answer and we know that it's 14 days. Some of us can just do that straight out. And the next step we would be is, okay, well, we have 14 days. Let's convert that into hours. So we say that there's 24 hours in 1 day. And how many hours will there be in 14 days, right? And if we do this out, we get 336 hours. And we can continue on from hours into minutes, and we can say, okay, well, there's 60 minutes is 1 hour. How many minutes if I've got 336 hours? And that's going to be about 20,160, I believe, minutes. And you can continue in this vein. So now we got to get to minutes. We can do the minutes to seconds, right? So we can take minutes and we can move that into seconds, kind of the same exact way that we've been doing. Now, that takes multiple steps. There's nothing wrong with doing that. You can also do it in an organized way. So all these ratios that we're making here, we can put them in a single straight line, and all we're doing is canceling out units. So this term dimensional analysis is just a fancy word for putting ratios together where we're canceling out units to end up with what we want. So let's talk about how we set up dimensional analysis. Now, if you look at dimensional analysis, there's many different ways to do it, but they all ultimately end up with the same thing. Just a string of ratios, and you're canceling units. So I'll show you one way that I like to do when I set them up. The first thing you do is here in part 1 is you draw a line with an equal sign. So here's a line. This is going to be a really big fraction line. I like to look at it. You have an equal sign. And then what you do is you place the quantity, right, that was given in the question, and you place the units you're looking for outside. So the units we were looking for is seconds, right? So I'm going to place that outside at the equal sign because that's what I'm looking for. Whatever units I'm looking for, that's seconds. The thing that I'm given in the question is 2 weeks. So I'm going to start with whatever info is given. In this case, I have 2 weeks. So I'm going to go along this line right here. So I'm going to go along my little line, and I want to eventually end up, so my units equal seconds. This is called the unit path, some people will call it, this line right here. And what we do is we usually just make a line above it, and that will be a break between one ratio and another ratio. So what we start to do is in number 2, right, it says that, okay, along that unit path, which is what this is, this line right here is the unit path, right? So unit path, you can call it. Along that line, you're going to start putting relationships, right, where we cancel out units until we get to seconds. So let me draw that one more time. We started with 2 weeks. I got my 2 weeks here. I have my line. I have my equal sign, which is where my seconds are. And I've got to start to do units, ratios, right here on top and bottom, so I can eventually start to cancel out seconds. So you can do it in any order you want, but I usually am going to start to cancel out the units I see here. So I have weeks. So in order to cancel out weeks, I have to have something in the denominator. So I'm going to say 1 week, right? And what relationship do I know about 1 week? Well, I know that 1 week is 7 days, right? Like we said before. That's one ratio right there. I'm going to draw a line. I'm going to put another ratio there. I want to cancel out the units. Notice that now the units here for weeks cancel out. right? I have now days that I'm left with, so I need to get those to seconds. So let me put 1 day down in the denominator. And in the numerator, I can say, well, 1 day is 24 hours. Right? Let me do that as HRS for hours. And now again, notice that I've got days cancel out. I'm left now with units of hours, but I want seconds. So let me again do another one. And let me say, okay, well, 1 hour, right, is equal to 60 minutes. And I know again that I've got my hours cancel out and I've got minutes, but I still need my seconds. So one last one should do it. I know that 1 minute is 60 seconds. So if I've got 1 minute and 60 seconds, and now finally I'm crossing out my minutes, and I am left with only units of seconds, which is what my units that I'm looking for. If I take my calculator out, so if I take my calculator and I start to multiply and divide each one of these, eventually I will get my answer. 2 times 7 times 24 times 60 times another 60 across. I've got that number there, right? Looks like 1,209,600 seconds. Right? That's the answer that I can get. Now, that same concept can be done when we talk about something in pharmacy. So let me give you an example here that we have. So in pharmacy, a lot of times we're going to be giving IVs. When we give IVs, we know that there's a IV bag, and that IV bag is going to be given into somebody's vein, typically, and it's going to be given over a certain amount of time. So we have a certain amount of fluid being infused in a certain amount of time. So I'm just going to draw a little IV bag here. This is an IV bag full of fluid. It's going to come down, and it's going to be given into somebody's arm right there. And this is a certain amount of volume, so this is a certain amount of mLs, and the rate at which it's flowing in the tube, or we call it dripping down into the tube, will give us information as to how long it might take to infuse that. So let's look at an example. It says the patient is to receive 1,000 mL. So this is how much is in this bag right here, is 1,000 mLs. Alright. And it's going to be infused over 8 hours. So we're going to have all this liquid right here infused over 8 hours into the patient. It says if you have a delivery set, which means that this IV set, this line right here, this line will deliver 10 drops of water, or sorry, the fluid that's being infused. So 10 drops of that liquid will equal 10 mLs, or sorry, 10 drops will equal 1 mL. So it says how many drops per minute will be infused. So if you had to set this for drops, the question is asking you how many drops would it take for you to set per minute so that after 8 hours all of the liquid inside of that bag, all 1,000 mLs, was infused in the patient. Let me say it one more time. You got 1,000 mLs. This is being dripped into the tube. Drip, 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 drip. If every 10 drips is 1 mL, how many drops per minute do I need so that after 8 hours all that's infused? So this is where that dimensional analysis question comes into play. So first thing is draw my unit path, draw my equal sign. Over here on this side we're going to place the units that we're looking for. The units in this case are actually drops per minute. So I'm going to have drops on the top and I'm going to have minutes on the bottom. That's the unit that I am looking for, drops per minute. And I'm going to start over here on the left hand side with what's given to me. I have 1,000 mLs and I've got 8 hours. Now I can put 8 hours on top here, right? I can put the 8 hours on top here, or I can put the 8 hours on the top, on the bottom here. Which one do I want? Well, I know that 8 hours is the time, so that's where I need to have the minute. So I'm going to have that on the denominator, and that mLs is what I'm going to convert into drops. So I'm going to use it this way: 1,000 mLs, right, has to be infused over 8 hours. That's what's given to me. That's my first ratio there. Now my goal is to start canceling out units until I'm left with drops per minute. So you can start with any one you want. You can start with mLs or hours. I'm going to start with mLs because that's the one on top. So I'm given 1 ml in the question. It says that 1 ml right here is equal to 10 drops. So 1 ml is equal to 10 drops. And now when I go ahead and I cancel out my units, I've got mLs canceling out and I've got drops left. Drops is what I want. I stop canceling units. Now I got to take care of my hours. I got to have hours be minutes. Well, as we have done before, 1 hour, right? So 1 hour is 60 minutes. And in that case, my hours cancel out, and I am left with the units of minutes, and my drops are still there. So now I've got my answer that will happen when I go ahead and do the math here, right? So I'm going to move this out of the way. If I've got my 1,000, right, dividing it by 8 times 10, I can divide that by 1, and then I am ultimately going to divide that by 60. And I've got 20.833, so it's 20.833. This is drops per minute. And we can approximate that to about 21 drops because we need whole drops. We can't get 0.83 of a drop, right? It's either 1, 2 whole numbers. So about 21 drops per minute. So this answer is telling us that if I went over to my IV set over here, if I set it so that 21 drops every minute came out of that over an 8-hour period, I'd have all 1,000 mLs delivered to the patient. So a good use of how dimensional analysis plays. Right? There's another way that you can also beat it. So in other words, in here, time is usually of the essence. So anything you can do to speed up time is good for you when you're answering questions. So here, this says how many drops per minute, right? And what can happen is that you know that is over an 8-hour period. So you know you have 8 hours and you know eventually you want to have something minutes. You can convert those 8 hours into minutes right away. So you can say, okay, as I have here, 60 minutes is in 1 hour. How many minutes is there going to be in 8 hours? And you get 480 minutes. So what that means is that in this unit path that we did here, in this unit path right here, this first ratio right here, instead of having 1,000 over 8, you would just have your 1,000 mLs over that 480 minutes. There's nothing different than what we did before. The only difference is that I'm avoiding some of the math over here. If you find it easier to substitute things before you place them on the unit path, go ahead and do that. And then here you would just have your 10 drops per 1 ml, so that the mLs cancel out and you're left with your drops per minute, which is the answer that we want. We get the same exact answer. So you don't always have to do the full dimensional analysis if you want to substitute at all, but don't get confused by that. If that's the case, whenever you would like to do the full or the shortened version, it's up to you, whatever you feel more comfortable with. Or you can always do, as we did in the beginning, each ratio step by step. You will always get the same answer. It just depends on keeping track of what's going on and what works best for you. All right. So that is dimensional analysis. And as always, pharmacy calculations is the most important subject because it's the only one that counts.